The question here is find the local minima and local maxima of this function. 1 for the function given here is x to the power of 5 minus 5x to the power of 4 plus 5x cubed minus 1. First find out f dash x. You take 5x square common and you try to factorize this. So this expression has been factorized into 4 factors. So for turning or stationary points, first derivative must vanish. Means either you have x is equal to 0, or you can have x is equal to 3, or you can have x is equal to 1. So at each point we are going to check what is the sign of the second derivative. Okay, so let's start with 3. 0 we'll see later. Let's first find out the second derivative, f double dash x. So we are going to use, say, this one here to find out the second derivative. We have 5 into 4x cubed minus 20 into 3x square plus 15 into 2x. Okay, so this will come to be 20x cubed minus 60x square plus 30x. From this now you can take 10x common. You get 2x square minus 6x plus 3. Okay, so this is what you are getting. You don't need to factorize this because we only need the sign. So we check at x is equal to 3, f double dash x is equal to f double dash 3. Put x is equal to 3 here. You get 10 into 3. You get 2 into 3 square minus 6 into 3 plus 3. So you get here 30 to 18 minus 18 plus 3, which is greater than 0. So that means fx has a point of local minima at x is equal to 3. And since minimum value is not asked, but still we want to calculate the minimum value, of fx at x is equal to 3 is, put it in the function, f3 is equal to 3 to the power of 5 minus 5 into 3 to the power of 4 plus 5 into 3 cube minus 1. You can calculate this to be minus 28. Okay, this is the minimum value. Now what is the next point here? The next point that we are getting is x is equal to 1. At x is equal to 1, f double dashed x is equal to f double dashed 1, 10 into 1, 2 into 1 square minus 6 into 1 plus 3. So you get here 10, 2 minus 6 plus 3, which is equal to 10 times 5 minus 6, which is less than 0. Therefore, fx has a point of local maxima at x is equal to 1. And we can find out the maximum value. Maximum value of fx at x is equal to 1 is f1 is equal to, you put the value in the function, 1 to the power of 5 minus 5 into 1 to the power of 4 plus 5 into 1 cube minus 5. You can find this out to be minus 4. Now the third point here that we have not considered till now is x is equal to 0, this point. We'll consider this point. At x is equal to 0, f double dashed x is equal to f double dash 0 is equal to 10 into 0. Put it in the function there. 2 into 0 square minus 6 into 0 plus 3, which is equal to 0. So you see that the second derivative vanishes here. Okay, if the second derivative vanishes, you must find out the third derivative. And for third derivative, you don't need to check the sign. You just need to check whether third derivative is equal to 0 or not equal to 0. So let's first find out the third derivative. Third derivative, from where will you calculate? You can calculate it from here. Okay, so 20 into 3x square plus minus 60 into 2x and plus 30. This is the third derivative. We simplify this. You will get this as 60x square minus 120x plus 30. From which you can now take 30 common to get 2x square minus 4x plus 1. Okay, so this is f triple dashed x. Now you check whether this is equal to 0. At x is equal to 0. F triple dashed x is equal to f triple dashed 0. Put the value 30, 2 into 0 square minus 4 into 0 plus 1. See this, you get this is equal to 30, which is not equal to 0, right? So that means thus x is equal to 0 is a point of inflection of fx. Okay, so that finishes this part. So what are the turning points here? The other 2 points. The turning points of fx are obtained at x is equal to, what were the other 2 points? X is equal to 3 and x is equal to 1. and x is equal to 0 is a point of inflection. Okay, moving on to the next problem. One five. Let fx is equal to sin x plus cos x, where x lies between 0 and pi by 2. So first differentiate this. F dash x is equal to cos x minus sin x. You're going to get. Now for turning or stationary points, f dash x is equal to 0. That means cos x minus sin x is equal to 0. Then sin x is equal to cos x. Sin x is equal to cos x means tan x is equal to 0, 1. Okay. Now tan x is equal to 1 means because x lies between 0 and pi by 2, tan x is equal to 1 means tan pi by 4. That means x is equal to pi by 4. Why only tan pi by 4? Because we see that x lies between 0 and pi by 2. Now we need to check at x is equal to pi by 4 whether we get a maxima or a minimum. So find out the second derivative here. Minus sin x minus cos x. And this has minus sin x plus cos x. Now you check at x is equal to pi by 4. F double dashed x is equal to f double dashed pi by 4 is equal to minus sin pi by 4 plus cos pi by 4. You know both the values are root 2. So obviously this is negative. That means fx is equal to sin x plus cos x has a local maxima at x is equal to pi by 2. And what is the maximum value? Maximum value of fx at x is equal to pi by 4 is f pi by 4 equal to sin pi by 4 plus cos pi by 4. 1 by root 2 plus 1 by root 2, which is equal to 2 by root 2, which is equal to simply root 2. Fine. Moving on to the next sum. Number 2. The question here is a quadratic function in x has the value 19 when x is equal to 1 and has a maximum value when x is equal to 2. Find the function. Now quadratic function, what does it mean? Quadratic function means I can take fx is equal to ax square plus bx plus c. It's a quadratic polynomial where a, b, and c are constants. Okay. Now this function has a value of uh, 19 when x is equal to 1. So when x is equal to 1, f1 is equal to 19, right? So put it here. What is f1? A into 1 square plus b into 1 plus c is equal to 19. That means you get a plus b plus c is equal to 19. This is the first equation that I'm getting. Next is it has a maximum value 20 when x is equal to 2. So whether maximum minimum, it definitely has the value of 20 when x is equal to 2. So when x is equal to 2, f2 must be equal to 20. Whether maximum minimum we'll use later. But what we definitely know is that when x is equal to 2, the value of the function is 20. So that means a into 2 square plus b into 2 plus c is equal to 20. So you get 4a plus 2b plus c is equal to 20. Okay, this is your second equation. Fine. So you get equation number 1 and 2, but there are 3 unknowns. You should have a third equation also. We'll now use the fact that this has a maximum value. Then now see uh, what is f dash x. If you differentiate this function here, fx, you're going to get 2ax plus b, right? Now, if this function has a maximum value when x is equal to 2, that means if fx has a local maxima at x is equal to 2, that means f double dash 2, sorry, f dash 2 must vanish. Whether maximum or minimum does not matter, but f dash 2 must be equal to 0. Now put it here. What is f dash 2? 2a into 2 plus b must be equal to 0. That means you get 4a plus b is equal to 0. This is the third equation. So equation numbers 1, 2, and 3, you need to solve. Okay. So how will you solve these two equations? These three equations? So what you see from 1 and 2, look at these two equations. If you look at these two equations, you have a plus c here and you have a plus c here. That means if you subtract these two equations, you can get rid of the c. Let's get rid of the c first, because and in the third equation, you see there's no c. So what you see is you can subtract these two equations. This cancels here. So you get minus 3a minus b is equal to minus 1. That means you get 3a plus b is equal to 1. Call this 4. Now in order to solve for a and b, we can use 3 and 4. How to solve these two? Subtract 4a plus b, 3a plus b. This is equal to 0. This is equal to 1. Subtract these two equations. This cancels. So you get 4a minus a, and this is equal to minus 1. That means you get a is equal to, you are getting here, a is equal to minus 1. Okay, when was the value of this equal to, okay, at x is equal to 2. This is okay. So we're getting a is equal to minus 1. Okay, now how will you get the value of b? You put it in equation number 4, putting a is equal to minus 1 in 4. we get 3 into minus 1 plus b is equal to 1. That means you get minus 3 plus b is equal to 1. Means you get b is equal to 3 plus 1. Means you get b is equal to 4. We have solved for a and b. How about c? You got the value of a and b. You can put it in 1 and get the value of c. So putting a is equal to minus 1, b is equal to 4 in 1. We get the equation was a plus b plus c is equal to 19. So a plus b plus c is equal to 19. That means you get 3 plus c is equal to 19. That means c you get as 19 minus 3. C is equal to 16. Okay, so therefore, hence, what is the quadratic function? Fx is equal to ax square plus bx plus c. This is a required quadratic function. Okay. Last sum. Now look at this. Number 3. The function y is equal to a log x plus bx square plus x has extreme values at x is equal to 1 and x is equal to 2. Find a and b. Now what do you mean by extreme values? Extreme values means that it either has a maxima or a minimum at x is equal to 1 and x is equal to 2. We don't know which one, but it definitely has some extreme value that is either a maxima or a minima. And you know that for a maxima or minima, the first derivative must vanish. That means first derivative is 0 at x is equal to 1 and x is equal to 2 both. So let us first find out the first derivative. Dy dx is equal to a ddx of log x is 1 by x plus b ddx of x square is 2x and ddx of x is 1. So you are getting here a by x plus 2bx plus 1. This is what you are getting. Now for extreme values, dy dx must be equal to 0, right? So at x is equal to 1, you must have dy dx at x is equal to 1 must be equal to 0. Put the value a by 1 plus 2b into 1 plus 1 is equal to 0. So you're getting this as a plus 2b plus 1 is equal to 0. Call this equation number 1. Also, at x is equal to 2, you have an extreme value, right? So you put x is equal to 2, dy dx at x is equal to 2 must be equal to 0. So now you put it in the function. So you have a by 2, a by x plus 2b x plus 1 is equal to 0. That means you are getting a by 2 plus 4b plus 1 is equal to 0. You take the LCM, you get a plus 8b plus 1 by 2 is equal to 0. That means a plus 8b plus 1 is equal to 0. So this is your second equation. Now we are going to solve equation numbers 1 and 2. How do you solve? You subtract. A plus, this is the first equation, a plus 2b plus 1 is equal to 0. Second equation is a plus 8b plus 1 is equal to 0. Subtract these two equations. So you get 2 minus 8 is minus 6b, and this also, um, you get this as 2, sorry, this is not 1, it's 2. Okay, so this subtract, you get this as 0. So you get b is equal to minus 1 by 6. Okay. Now you put b is equal to minus 1 by 6 in 1. Any one of the equations you can put. A plus twice b plus c is equal to 0. Since now you cancel, you get a minus 1/3 plus 1 is equal to 0. You get a is equal to 1/3 minus 1. That means you get a is equal to minus 2/3. Okay. So you've got the values of a and b. So a is equal to minus 1/3. A is equal to minus 2/3. And b is equal to minus 1 by 6. That's what they had asked. Find the values of a and b in the question. Find a and b, and that is done. Okay. Time's up. So I'll stop here.